So we are back here, and now we are with this gentleman called Álvaro Salvá Lezaun. He was born in the best place of Spain. He's claiming that, from Mallorca, and is currently working in Barcelona. He is a sysadmin that he loves. I mean, he likes good talks. He used to be a developer, but now he works passionately with servers, networks, monitoring, availability, cloud. I mean, a bunch of things here. And he's trying to deliver value as fast as he can by means of continuous deployment. So it's your time, Mr. Álvaro.
Hello, I'm glad to be here. Thank you for the organizers to organize this. My name is Álvaro, and the most handsome, elegant, and humble system administration you have made to date. And today we are going to talk about continuous deployment with Git operations. And what is that? Let me show you. So I'm going to explain what, the whys, GitOps, the flow that we are following in our company, and question and answer. So let's talk about a little introduction about what is the difference between integration, delivery, and deployment. Many of you know, so very quickly, integration. What is integration? Integration is when you upload a code or a system change or whatever to something that already exists. How does it integrate with the whole system? Is it okay? Is it not? This is integration. Okay, and then continuous delivery. What is delivery? Think that, for example, if you are working for a big company and that company orders that you are doing a software for the internal computers. That's it. You are not going to touch them. How are you going to deliver your work? Maybe with a pen drive, maybe with something else. So this is the delivery. You are delivering to the customer something. You're not deploying, but you have delivered. You and your money. That's it. And now let's talk about the deployment. So I think you have guessed it. Deployment is when the software is ready to consume by the final user because it has been deployed somewhere. With somewhere when you can actually feed the customers with that. Okay? And now let's talk about the word continuous here. What does continuous mean? What is the difference between non-continuous and continuous? To me, continuous means that you are deploying very often, that you are deploying several times per day, per hour, whatever. If you, for example, build an awesome automatic way of deploying all the time, but you use it once a month, no matter how automatic it is, in my opinion, it is not continuous at all. Continuous means that you are deploying, you are delivering value faster and better. This is continuous deployment. It's widely accepted, but the difference between delivery and deployment is that it's the automatic step to deploy to production. Well, we can debate about that. It's a really interesting debate. What are the advantages of continuous, really continuous deployment? We deliver faster and better. So we have less time to market to reach our final users, and we are ahead of our competitors. But the best advantage for me as a system administrator is that I'm avoided the releases and painful deployments all the day. Back in the day, years ago, I used to spend a full day or half a day deploying a release into the production servers. That was insane. That was insane. That meant that I made mistakes a lot because it was such a manual process. It was a pain. The executive team was nervous because it was kind of an issue, and it was a problem once a month, once a week. It was, I don't want to get back there. Never again, please. So if something hurts, you have to do it more often. It's like if you go to the gym once a month, you will end exhausted. If you clean your house once a month, you will have a lot of work. But if you do it every day, a little bit, you will get better and better and better and better, and you will have value constantly, every day. What are the consequences of all this? Well, happiness, because the team doesn't have the burnouts that they used to have deploying manually with a lot of time involved. But now let's talk about why not, why you shouldn't apply continuous deployment. Maybe if you are starting with a side project, okay, or you are starting from scratch and you are on your own, or you and a friend, maybe it's not worth to spend several days working in an automatic fancy system. Start little by little, okay? I did pull an FTP load for the really beginning. In my opinion, is okay as long as you don't extend that into the long future. You can do it lean. Maybe you can do it this the first week, and then the next week you have to improve it a little bit. The next week I'll improve it a little bit. If you are already with a big system and you need to deliver faster, okay, then it's worth the effort. Okay. Now I'm going to tell you how we achieve it. But before that, I'm going to put you in some context. I'm going to explain how our environments are installed, so you know when I speak about them. We have two clusters. One, the development environment, where we have the staging environment, the QA environment, sandbox for the mobile users to consume them. We have also ephemeral environments where the developers can test their images, their features before going live. And you have tools also in order to help the development, like Jenkins, for example. These are one Kubernetes cluster, as you might guess it. We have also another Kubernetes cluster in another separate LWS account. This is the production one, which we have the production namespace, obviously, monitoring tools, the website, and tools that help us with operations like Flux that I'm going to explain further on. We have, obviously, more things than these two clusters, mostly EC2, RDS, DynamoDB, RabbitMQ for the queues, Redis, and New Relic for monitoring. What else? Well, this is really important because we have the backend services to store data mainly. We had bad experience back in the day with persistent data in Kubernetes cluster. I don't recommend it for production level. The persistent volumes and persistent volume claims are okay in Kubernetes, but we had latency issues back in the past and reliability. So we decided to store data somewhere else, not in the real Kubernetes cluster. We do for development in some cases, but we try with all of our efforts to install in the Kubernetes cluster stateless application, not stateful applications. So how we did deploy here before 2 years ago? We were using Ansible. And Ansible is great. We were using Ansible to apply the configuration to Kubernetes cluster. We actually use Ansible because we were doing the deployments as configuration management system and deployments in the past with the EC2 machines. And it worked. We use Ansible with kubectl applies -f on the template and parameters. This is what we used to do. And we continue doing that back in the day. But this has some issues, like human mistake. I could make a mistake also. We could have an outdated version of Ansible. We could have an outdated version of the playbook. We could forget some parameter. That's normal. But the most important thing here is that the developers needed us to deploy to production. So we used to go to a room. We used to do the deployment ritual, the QA, the system administrators, the developers all together and do the deploy. We put music, it was fun, but if you want to do this continuous, it's hard to scale, okay? So we tried to fix that using Jenkins. in order to push a button and the Ansible would run, but still we had the main issue. What was that issue? That issue was that the developers didn't know how to deal with Ansible pages to the details. Moreover, we didn't provide the means to them to do more with deploys and infrastructure changes. So I share the blame. This is uncomfortable, but this is true. We didn't provide the developers for an environment to do it. And why this is important? Well, I do think that the developers should be able to deal with all the development cycle from the beginning into the end, including operation, including scaling. You know better than anyone how your application is going to scale because you have programmed it. The system administrator doesn't. You know better than anyone how much memory are going to use per instance. You know how many instances they are going to use. You know you need persistence. You do. So why don't we provide you with the tools in order to achieve that? Easy. But I'm not going to add much more fuel to the fire. Okay, so how did we achieve that? With GitOps, Git operations. This is an idea that came out in order to fix that issue. Git is used, as you know, as a version control system. I upload your code, you upload your code, we merge it, we solve conflicts. It's great to work within a team. Great. Why don't we use it to use it as a single source of truth for what is deployed in the cluster? The problem before that we had is that we didn't know what versions we had in production, for example, and the developers used to ask us, which is the version of the subscription service because in production, because we are having an expected behavior and we don't know how to deal with it. And we had to go and say, okay, kubectl, edit deployment, blah, 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 and see what was the deployment. And now what's going on with Git? The developers perfectly know how to deal with Git, how to operate with Git. They do know. They know how to roll back to a certain versions. They know how to push a new commit. So you don't have to hardly explain anything. It's already there. You don't need to learn Ansible. It's fine. Ansible is good. But with Git, you don't have to learn it. You already know. So for the declarative infrastructure, we have this repository, one repository per cluster. So we have the production repository and the development repository. And also the applications we use with help. Which version you have and what are the values that you need, what are the parameters that you need for this release to be on production. In order to deal with all of this, we use a program called Flux from Webworks. Maybe you are a fan of Webworks, maybe you are not. This is something that, in my opinion, works really well. You are reading the Git repository all the time. And if you change that repository, the change goes to the cluster that is configured with Webworks. If you want to install it, there is a guide in their GitHub. There's a couple of kubectl applies and kubectl in order to store encrypted data into the repository. So the Kubernetes cluster gets updated right away with what it is in the repository. And just that is the ultimate single source of truth. What is in the repository goes to production or is in production. That's it. Okay. Let me show you an example. This is a Helm release installed in production. As you may see, you have the subscription service that is going to be installed, the version that we are going to install, where the image is, which variables we are going to use, CPU, RAM, resources, request, limits, scaling, horizontal product scaling configuration, whatever you need. These values has to be supported by the chart. What is a chart? Very quickly, a Helm chart is the metadata of the software that you want to install. It can contain the service, ingress rules, deployment configuration in a template, and then the values that you are going to feed that template with. And those values can be here in this specification right here, values. So you can have separate the same template, the same Helm chart for the production and development environments, but you can change them. You can change the parameters in Git with this. And final picture, what do we have here? Yes, you guessed it. The dirtiest PowerPoint slide you have ever seen. And now, I'm going to tell you how we did the flow with GitOps. Okay, maybe it works for you. Maybe it doesn't. I hope it do. Let's focus on the goal here, okay? What is the goal? The goal is that if we merge to master, the service is deployed in production. Okay, I think it's important to focus on this. Okay, I'm going to get a little bit serious here. If you are deploying a software and you want to deploy in production, you have to clear the goals that you want to achieve. The tools will be the ones that are necessary to achieve that goal. Please don't do it otherwise. Don't start by the tools because they are cool. Don't start by the tools because everybody is using them. Use it because they are okay to reach your goal, to get to the finish line. And then you will succeed. Speak with your team, know which method is okay to reach your common goal, and then you will be success. No matter if you are using a tool and I'm using another one, that's fine, but be clear that in order to get the service deployed in production, from a change that I do in my apps repository, we need some magic to get there. That's it. And then you may ask, okay, Álvaro, what is this magic? I'm going to show you our process. For starting, we have, as you know, a pull request merge in the master repository. Great. What else? Then we generate the artifacts automatically. This is a Jenkins pipeline, by the way. Okay. We generate the artifact, the Docker image, whatever is needed, your npm install, whatever, to build what you have to do in order to get this to work. And the Helm chart, obviously, okay, with the version number. Then we do a pull request to the production repository. Why? Why here? Why now? Well, you are going to request a deploy, aren't you? Then you got it. This is the starting point, a pull request. And the pull request will merge only when all the conditions are met. And which are those conditions? In order to get them, we need to install it in the development staging environment in the development cluster. Obviously, using GitOps too. So we do a pull request in the staging repository and it's auto-merged after some conditions are met. Like, for example, YAML int and any other preconditions that you may want to check. Does the image exist? Does the chart exist? So I merge it in staging automatically after some comprobations are done. Once it's deployed, this is the happy path, by the way. Once it is deployed, we do the regression test. There are custom for each service. Why do I say that? Because the regression test, we had a very long one where it took a lot of time in order to end. So the QA team did a mapping in a JSON file saying, okay, this service has to run this test. So we consume that JSON file and we execute the tests that are necessary for this service in particular. For example, if one service doesn't require payments, maybe it's not needed to test all the payments and register a user, pay, sandbox. Well, after the regression tests are green, okay, we have the goal. We merge the pull request that we have in the production repository. This one now is merged here. And what happened when Flux detects that change? Oh, there is a change in the master branch, or I apply everything, whatever you want to configure, and there you go. It is deployed. Great. Awesome. Now we run the smoke test. Okay. In order to make sure that we haven't broke anything, and everything runs fine in production level. But it's already deployed. It is already deployed. Okay, we have to roll back then, we have to roll back, but it's deployed. And then we send a notification as Slack and New Relic to make everyone sure that it has been deployed. We didn't have that before, and the developers were asking us all the time, when is my service deployed? When is my service deployed? I don't know. I don't have any feedback. So using the Slack API, we put a notification. This service has been deployed. We have a pull request in production for this service. So we keep up to date in a certain channel of all the deployments that are going on in the company. And then we get a fancy sound at the office. That was my love before. My teammates did a joke with me. So every time something gets deployed, everyone in the office hear my love at the TV. And I can assure you that was several times a day. So now we have changed it to a Mario Bros theme, and we're happy with this. So every time our developers merge something to the master because they want to deploy it, 5 minutes, 10, and then Mario Bros is sounding at the office. Cool. Awesome. We are there. And how did it go? Well, let me show you an example. This was 1 week, just 1 week before we set up this process. In that day in particular, we had 17 deploys. And in that week, 56. I'm really proud about this. I'm proud about the developers that had the guts to do it. I'm really proud about the QA team that did this awesome test and this awesome flow in order to achieve this. And this is the final result. I hope it was for you. I hope it settles a little seed in your brain in order to get to continuous delivery, really continuous. I think it's profitable for everyone. And now I'm going to ask you to answer your questions. So please, master of ceremony, I'm ready to go.
Thank you very much, Álvaro. Was great. And we have a bunch of questions, but since we have already 6 minutes, I need to pick 2 or 3. So okay. The first one will be, how do you structure your repositories for deploying to different environments? One branch per environment, folders by environment, or different repositories?
Okay, what we are doing is everything is the same branch. So we have folders for namespaces, really. And we have the QA folder, the staging folder, and you do a change, you do the pull request, and then it's merged everything. So there is no isolation, really. It's about folders. We have to care about this.
The second one would be, how do you deal with secrets? Do you encrypt them inside the Git repo, or you're storing them externally, like using Hardship of Vault or stuff like that? Okay,
yeah, that's a really good question. We use a tool called KubeSeal in order to seal the secrets that we are uploading to. As this friend stated, it's dangerous to upload secrets and passwords into a Git repository because everybody can read them. So make sure that they are encrypted. We use KubeSeal that they get encrypted before with a GitHub hook before uploading, and then it's uploaded there. And when downloading, it gets unsealed. But you can use Helm secrets too. A lot of people use that.
Okay, related to what you were mentioning about hooks, someone is asking you if you're in favor of using hooks, and what happens if a webhook doesn't trigger, it doesn't like send whatever you're looking for. How do you manage that?
Well, obviously the system is not perfect. If something is not working, like the hook, it never happened, but it can happen. We have to manually trigger it again. Sometimes we have to go to the Jenkins and do build because something didn't work through the process. But this is like unlikely, to be honest.
Okay. So there is another question. Since you are replying very quickly, we have time to almost pick it all of them. How do you deal with failed deployments and have the repository synced with the latest version of the latest version deployed?
Sorry, can you repeat the question?
Yeah, it says, how do you deal with failed deployments and you keep the repository up to date?
Okay, with failed deployment, that's a really good one. If something has gone wrong, for example, in the application that has not the behavior that we expect to, I ask the developers to do another push into the master branch to fix this, and then it gets updated right away. Okay. Another way of fixing this is to go to the Flux repository, to the GitOps repository, and put the previous version, like a revert or something, do a new commit, and push it to master, pull request to master. And then you are in the previous scenario. The good thing about Git, about all of this, is that you can go to a previous state very quickly, and you know how to do it.
Okay. Last one, because we have 2 minutes left. Quickly, what is the meaning of GitOps repository? Is a repository only for the infrastructure and deployment code or application code? Can you do you have any public example where you can share with? That's something we can share afterwards.
Yes. A GitOps repository is just a repository separate from your application repository. That's another with the declarative infrastructure of the cluster. That's it. So we have workloads with secrets, persistent volumes that we need, secrets, whatever. And then we have a separate folder with the releases, with the Helm releases that we want the cluster to install. That's it. There is nothing else. There is no app code. Just this. Very simple. And you have another cluster, set up another repository for that one.
Great. Cool, then. Thank you very much, Álvaro. We enjoyed a lot.
You're welcome.
And thank you very much. Bye, guys. See you now in a couple of minutes.